Greetings viewers and welcome to Fatal Sec. In today's tutorial, we will delve into the fascinating world of reverse engineering for Flutter-based Android applications. I see on our Telegram channel and also on YouTube comments that many people are struggling with analyzing Flutter-based application and have been requesting this kind of video. So if you have ever found yourself struggling with the intricacies of analyzing Flutter apps, then this video is for you. Okay, so first of all, let's address the situation why it's difficult currently to analyze or reverse the Flutter application. The thing is that over the years, a lot of tools have been developed to help us analyzing different binaries. However, when it comes to Flutter, there are not many tools available and still many famous disassemblers such as IDA, Radare or Ghidra does not support Dart AOT Snapshots out of the box, which basically contains all the application code, and this is what we have to analyze in a Flutter application. More or less, when you try to open this native library which contains Dart AOT Snapshot in any disassembler, it will not show you any useful information until unless obviously you know how the Dart AOT Snapshot looks like. Okay, so as always, this time also we are going to use a sample application, and this time I am going to use an open source application called Funny Bones. This app simply fetches a joke from a web server and displays it in the app UI. And if you want to follow along, let me show you from where you can download the source code of this application. So this Funny Bones application is available on GitHub, which is developed by this user. I am Pawan. So you can simply download the source code in a zip format and then build it for yourself. For the sake of simplicity, I will upload this APK file in our GitHub repository, the link to which I will mention in the description box below, so you can download directly the APK file. Okay, now let's see how this application looks like. We can observe that it shows a joke in this little card, and then we have a button down below to add a new joke. Let's see what happens when we click on this add new joke button. Okay, it basically adds a new joke into the list. Unix is user friendly, it's just selective about who its friends are. Haha, very funny. Okay, another thing to observe here is that if we don't do anything, after a few seconds or minute, it automatically fetches a new joke and adds it into this list. Okay, so let's wait for a few seconds. And as you can see, a new joke has been added automatically, right? So that's what the application is all about. Let's now try to reverse this application, but before diving into the reverse engineering part of this application, there is an important thing to note that in Flutter based application on Java layer, you will not find anything useful. All the app logic is built into a native library called libapp.so. So instead of wasting our time by looking into the decompiled Java code, let's directly extract the application using APK tool and look into its library folder where all the shared libraries are present. So let me go into the directory where this application is present, which is under training 2024 Flutter RE. Okay, there you can see we have this app production release.apk. Let's extract it using apk tool decompile app production release.apk. Once the APK tool extracts the content of this APK, we can directly go inside this app production release directory, then into the lib directory, and then we are interested in analyzing the ARM64 version of the library. So let's directly go into that. And over here, we actually have two native libraries present. One is libapp.so and another one is libflutter.so, right? So in any Android application, after extracting it, if you see in the libraries section these two libraries, then you can say that the application is based on Flutter framework. Okay, so let's slow down a little bit now and let's try to understand some concepts first. Firstly, what these two libraries are exactly. This libflutter.so is what we call a Flutter engine. This library contains the core Flutter framework code compiled for the native platform. In this case, it's Android. It basically includes the implementation of Flutter's rendering engine, widgets, and other essential functionalities. Basically, this Flutter engine is responsible for executing the Dart code which is used to develop the application. Okay, think of it as a virtual machine which executes the Dart code. Then we have libapp.so, which contains the app logic written in Dart. So all the app's business logic is present in this shared library. most of the time we are only interested in this libapp.so because that's where the application logic is present, which is developed by the application developer, and that's our target, right? So to understand it better, let's first try to follow the usual steps which we do while reversing any other native library. So this time again I'm going to use Radare because that's my go-to disassembler. So to open this library into Radare, we can simply type r2 and then libapp.so. Then to analyze this library in Radare, we have to pass 6 times A to perform in-depth analysis. This will take couple of minutes because the library is pretty big. Once the analysis is done, let's try to list all the imported functions using II command. And there are no imported functions. Unlike typical ELF binaries, which usually have non-empty imported tables, these libraries lack such imports. Now let's try to list down all the strings present in this library using IZZ command. Oh, it identified more than 37,000 of lines of string. Okay. So in the result, you might see certain interesting strings. Let me scroll up a little bit. And there we go. So you can observe some interesting strings over here, such as JSON decoder, handshake exception, HTTP overrides, heap snapshot. Let's see if we have any string related to the joke itself. So let's try to search joke over here. We can see that it has a Dart file called joke.dart. Okay. What else do we have? We have joke block.dart, then joke list key. Okay. Then we have failed to fetch joke. So, okay, by analyzing these string, we can make some sense out of it. Like, okay, there might be a web API being called to fetch the jokes, and when it's getting failed, it's simply using this string to print some exception or error message, right? Then we have saved joke successfully. Similarly, we have something called fetch joke. So all these strings are present in the RO data section of the library, and by the naming convention of this string, it could be a function which is used to fetch the jokes, right? So let's try to find the cross references to this string and see whether it can lead us to a place from where we can further analyze it. So this is the address of the string where it is hard coded, and in order to find the cross references, we have axt command followed by @ and then the offset. Hit enter and it returns nothing. So we cannot say where this string is being used in this library. Similarly, you can try finding the cross references for other interesting strings, but the chances are that you will not find the cross reference to that string. Okay. So what else we can do? So there is something called exports, right? Let's try to list down the exported functions using IE command. There we go. So these are the exported functions listed out by Radare. And finally, we have found some information related to Flutter. Okay, so in the exported functions, we can see we have Dart VM snapshot instructions, Dart isolate snapshot instructions, Dart VM snapshot data, Dart isolate snapshot data. Okay, so before moving forward, we have to understand what a snapshot is and what a isolate is in Flutter framework. So in Flutter applications, basically Dart's isolate model is employed, where each piece of Dart code runs within an isolate, which is nothing but a self-contained execution environment having its own memory heap. You can think of them as threads, but unlike multi-threading where multiple threads share same memory space, isolates don't directly share memory. Instead, they communicate with each other by passing messages. Okay. Then we have something called a snapshot. A snapshot basically represents the serialized state of Dart VM at a specific point during the execution. It includes both the heap data, which is our isolates memory, and the natively compiled code. So most of the time we are only interested in the snapshot data because this is the section which contains the natively compiled code. So to better understand the snapshot structure and how it looks like in memory, there is a very neat block diagram available which you can see here on your screen. So First of all, it has header, which begins with a magic number, just like any other binary. Okay. Then we have a field for a snapshot length, which basically contains the overall length of the snapshot. Then we have a enum field which contains the type of snapshot. So if you go into further details of snapshot, there are different kind of snapshot used. Okay. Then we have something called the feature list, and in between these two there is a version field also which contains the snapshot version. Okay, similarly after the header section there is a cluster followed by the heap, you can say, and so on and so forth. So let's see this information in action. So if we seek to Dart VM snapshot data, which is present at this offset, right? Let me copy it. Seek to this offset using S command. And then let me switch to hex mode. And now we have the byte. So you can observe here that this Dart VM snapshot data section is starting with F5, F5, DC, DC, right? So this is the magic number of this snapshot. So whenever you see these bytes, you can say that it's a Dart VM snapshot data. Then right after these magic bytes, we have a field for length or the size, which tells the size of the snapshot, right? And the length field is actually of 4 bytes. So D73500000 all the way up to here, these particular bytes are basically used to identify the length of the snapshot. Then after that, we have the enum field which tells the type or the kind of snapshot. In this case, it's 3, and again it's 4 bytes. So from here up to here, this is kind field, which is a AOT snapshot. Then right after that, we have the version field, which tells the version of the snapshot. And you can see a much better interpretation of these bytes over here. So the 7D, BBD, 8EF, all the way up to 36DE. This is the snapshot version, or you can say the hash of the snapshot. Similarly, you can interpret rest of the information, but manually interpreting all the information is very tedious and not efficient. That's why there is a need of a parser to parse this snapshot so that we can extract useful information from it. Now, there are a couple of options available to parse the snapshots, such as RE Flutter. Maybe I will create a separate video about this tool sometime in future. If you guys are interested, let me know in the comments down below. But for today's video, I am going to use another tool called Blutter. Blutter. The reason why I chose Blutter is because it is not Dart version specific. So the thing with Flutter framework is that with every new release, the structure of Dart VM snapshot gets changed, which make it very difficult for a tool to parse all different versions of the Dart VM snapshots. And that's why till now, all the tools are struggling to keep up with the latest versions of the Dart. And this is where this tool shines, as it downloads and compiles the specific Dart runtime which is used in the target application to parse the snapshot. Disclaimer, it may not work with very old Dart versions, but with the recent ones and the latest ones, it works flawlessly. Okay, so this tool basically you can download from the GitHub repository. So this is the GitHub repository for this tool. All right, and you can either simply download it as a zip file or clone this repository. And let's go to our working directory, which is under documents training 2024 Flutter RE, right? Let me clone this repository over here. Once it's downloaded, we can simply go into this directory, which is Blutter, and list out its contents using ls-all. Here we have couple of interesting files and folders, such as this scripts folder. We will talk about this later, but first we are interested in this blutter.py, which is the one we need to run in order to pass the snapshot for our target application. Okay, so to run it, make sure you have all the required dependencies installed. If not, you can install them simply by executing this command apt install these packages. Okay, once the dependencies are installed, we can run this script using this command python blutter.py, path to our application lib directory, and then the output directory. Okay, so I have these dependencies already installed, and we are into this Blutter folder as well, so we can directly execute this blutter.py using python 3 blutter.py followed by the path of the application library folder, which is // production release lib arm64, right? And then the output directly, let's call it as out directory. Hit enter, and now you can see that it has identified the Dart version as 3.1.3 and the snapshot version as 7D, this one, right? Now you can compare this snapshot version with this one, which we have identified manually. It's the same. Okay, then you can see that it's cloning something into the Blutter, which is Dart SDK for version 3.1.3, which is the version with which the application is compiled with. Okay, once the specific version of the Dart SDK is downloaded, it will start building it. Okay, give it some time because building the SDK is quite resource intensive. Once it's done, it will generate some very useful scripts such as the Frida script, as well as it will give the whole assembly dump under this assembly directory. So here we have our out directory, and let's go inside this directory to see what all stuff we have over here. Over here we can see there is this ASM directory. So this is the one which I was talking about, which contains the disassembled code of the Flutter application, or I would say the Dart AOT snapshot. Okay, so after the assemblies directory, we have blutter underscore frida.js, which is the Frida script. Similarly, it also generates some IDA script. So if you are interested in using IDA, then you can utilize these scripts. Basically, it will map out all the symbols and functions and strings which it has found. After that, we have something called objects.txt and pp.txt. So before looking into the assembly directory and the Blutter Frida script, let's see what these objs.txt and pp.txt are. Now we have to more or less deal with the contents we have in this directory. So let's open it up in the VS Code. Our working directory, which is Flutter array, is already loaded here. And this is the Blutter directory under which we have our output directory, which contains this generated scripts and directories. So let's see what the pp.txt is. Basically, these two files contains the information about the objects present in the snapshot. One is this objs.txt and other one is this pp.txt. Okay, more often than not we will utilize this pp.txt because this is where all the objects are listed from the object pool of the snapshot along with strings and other data types. So this is the information which is being extracted from the Dart AOT snapshots object pool, and it has listed all the objects including the symbols, the fields, stubs, strings, right? So the information is very overwhelming over here. So what we can do in the beginning, if you remember, while analyzing the libapp.so in Radare, we stumbled upon the string called Joe, right? So I think it's better if we can identify some interesting objects which would be involved during fetching the joke or rendering the joke on the UI. Let's try to find the strings or symbol related to joke keyword itself. Okay, we have found a object called joke screen. By the name of this object, we can assume that this object contains the code related to the jokes screen, right? Which we can say is this one, right? As we are interested in the joke which is shown on the screen, I think this object is a good candidate. Now here comes the best part of this Blutter tool. It shows us the offset as well where this object is present in the Dart AOT snapshot. So for this, we don't have to go into Radare to look for this offset because it's part of the snapshot which it has disassembled under ASM directory over here, right? Now, if we peek into this ASM directory, we can see that there are a lot of directories present. And these are basically all the plugins and external dependencies which have been used in this application during the development. So it's quite hard and very time consuming to manually go inside each of these directory to see which one contains the offset we are interested in. To overcome this situation, let's make use of Linux grep command. So let me open the terminal over here. Let's go inside the output directory of Flutter, which is this one. And then we can run grep-ri followed by the offset, which is this one 4b9021. Okay, and then the directory in which we wanted to search, which is ASM directory. Hit enter. Okay, it found couple of places where this joke screen is present, and all of the references are coming from app.dart. Okay, this app.dart is actually coming from two different places. One is from the widgets package and another one is from the view package. So this app view package is the one which is the part of the application package, and this is the one which is part of the Flutter framework. So obviously we are interested in looking into the applications page. So let's open this file in the editor and see if we can find any useful information. So you see it says it's a app class which extends stateless widget. So if you're familiar with Flutter programming, there are two type of widgets. One is a state widget and another one is a stateless widget. I'm not going into the details of these because it's part of Flutter programming. So inside this app class, there is a build function, and this is the disassembly of the build function, where initially it has this enter frame, which you can say is the epilogue of the function. Then it's allocating some space for the stack, and then it has some stack overflow check. So you see here, along with the disassembly, it's actually telling you what particular instruction is doing at some places, right? Okay, similarly for this R4 equals to constant, it's telling that there is a list containing this, right? Then we have this popins function which is being called using BL instruction, and this popin function is part of this package. So all this information is generated by this Blutter tool itself, which is very useful and handy. Okay, so moving on, here we have this object joke screen, right, which is being loaded into the X1 register. So what we can say by looking at these assembly instructions is that there is nothing else we found other than this object joke screen. So basically inside this stateless widget, it's simply rendering the joke screen. But from this disassembly, we are not able to find anything related to the joke itself. So let's go back to pp.txt and look for some other objects related to joke. Here we have a string clear all jokes, and then right after that you can see there is a package funny bone src presentation screens containing joke underscore screen dot dart. Along with this page, it also shows us the class name, which is joke screen state, followed by the method name, which is clear all jokes, and this method definition is present at this offset. Okay, now this looks interesting. And by the name of this function, we can say that this method is most likely involved or responsible to clear the jokes which are loaded on the screen, right? But we are actually interested in something which is actually responsible for loading the joke. So let's see what other methods we can find. So we have another method called build inside joke screen.dart. So let's do one thing. I think this joke screen.dart is the file containing the methods related to the joke. So let's search this. Okay, we have found couple of more instances for clear all jokes. Then we have something called start fetching jokes periodically, and this function is present at this offset inside this joke screen.dart. Based on what we have observed from the application behavior is that it fetches the joke periodically, right, at regular intervals. So up till now you can see that it has loaded quite a lot of jokes, right? So this function looks like a perfect fit. Let's go now. Again, you can follow the same approach, grab this offset, but since we know that this particular function is present inside this joke screen.dart, which is present inside this package, so let's directly go to that file by following this path, which is funnybone src presentation screens and then joke screen.txt. Okay, here we have this class joke state and it has this build function, but we are interested in fetch joke, or what was the name of it? We start fetching joke periodically. right? So this is where this function is called inside init state. Again, in Flutter framework, basically init state is the method which gets called initially to initialize the state of the Flutter widget. It's okay if you don't understand this terminology because it's again part of Flutter programming, which we are not going to cover over here. So for now, just think of it as the main function which gets called whenever the widget is loaded on the UI. Immediately it will call this function, which most likely is responsible for fetching the jokes at regular interval. And we know that this function is present at this offset. So let's navigate to this offset instead. Okay, so here is the definition of this function. Now let's look at the disassembly to make some sense what's going on inside this function. So over here, initially again we have the epilogue of the function, then some stack allocation, some checks allocating the context. Then we have a function which is being called duration. So most likely this function is responsible to set the duration or the time interval at which the joke will be fetched. Right, then moving on, we have another function called timer.periodic, and basically that's it. Okay, so this function actually looks like a part of a widget and not the actual business logic which is actually used to fetch the jokes from the backend. The only business logic or interesting code I would say is this duration function. So if you want to manipulate the duration with which the application is fetching the jokes, this is the place. But for this video, we are interested in the joke itself, right? And you see it's quite a tedious process, and it also requires you to understand Flutter programming language itself and its different components such as widget, what is a state and a stateless widget, and how overall Flutter program works. So I would encourage you to go and understand some of the Flutter programming that will help you in better understanding the disassembly of the application. Now this time, let's look for something more concrete. Again, going back to pp.txt, something which guarantees that it contains the joke or the business logic. So from the application, we have observed that it's showing a list of jokes, right? This means that in the memory somewhere in the snapshot, a list data structure containing the jokes had to be created. So let's look for something similar. Okay, so let's look for something similar in our object pool. Fail to clear joke, success list joke. Okay, is there any object related to this? Okay, yes. So this object looks interesting. It says that we have an object called success, which is of type list joke at offset 4AF911, and it also takes one argument of type list joke indexed 0, which basically means a single joke. Cool. And this time we don't have the name or the path where this object is present, so let's again utilize the grep command -ri, then the offset where this object is present, which is 4AF911, and in ASM directory. Hit enter. All right, this time we only got one result, and it says that this particular list joke is coming from this joke underscore repository impl.dart. So let's open this file in the editor. Okay, it says there is this class which extends objects and implements joke repository, and it has this clear all jokes method. Nice. Get save jokes. Okay, then save joke. Okay, so it looks like all the functions are present in this. We have this fetch joke. Okay, so if you remember from our radare analysis which we did when we were looking into the strings of libapp.so, we found this fetch joke string over there, right, for which we were not able to find the cross reference. So I think this is the same function. So let's look into this disassembly, and obviously by the name of this function we can say that it's the function involved for fetching the joke. So again we have some basic stuff, allocating the stack, setting up the parameters, then it has the future result joke. This future basically suggests that it's the asynchronous task and the results will come at some later point of time. Then here we have fetch joke function being called using this bl instruction. And after fetch joke, it's actually waiting using by calling this await function. So like I said, the jokes are being fetched from the backend server or the web server, and it might take some time for backend to respond back, right? And that's why the application have to wait until the results are populated. And before moving further, there is one very important thing which I would like to highlight is that Dart AOT Snapshot does not follow ARM64 calling conventions as it is. It has certain similarities, but most of the registers or the way in which ARM64 architecture work, it does not work in the same way in Dart AOT Snapshot. What I mean by this is that the Dart VM engine has its own custom ABI implementation. But the good thing over here is that this Blutter tool actually rename those registers with the meaningful abbreviated name. For example, this FP register, it stands for frame pointer, and it's not the one which is used in ARM64. For the simplicity and understanding purpose, this tool renamed it like this. But if you go into the Dart SDK source code, okay, search for register, and if we go into the code section, here you can see different header files for different architectures. Let's look at the constant ARM one. This one is actually for iOS, but it doesn't matter. The architecture is same for iOS and Android, which is ARM. And over here you can see that R5 register is actually used for PP, which is object pool. R7 register is used for frame pointer. R10 is used for THR. R11 is used for again frame pointer for non-iOS. Similarly, R13 is used for stack pointer. R14 for LR. So you can find this kind of mapping between the Dart AOT snapshot architecture and the ARM architecture. But like I said, for the most part, the registers are same as ARM. So the return value is being stored in the same register as it is in ARM64, which is in X0. And the arguments of the function are passed in the same register as in ARM, which is starting from X0 to X7, right? So based on that, what we can say over here is that after fetch joke function is being called, its return value is stored in this X0 register, which is then being moved into X1 using this move instruction. Okay. After that, this await function is being called, and the result of that is being stored into the stack pointer from X0 register. And then it's calling JSON decode function, which is taking the value present in this X0 as its argument. Now we have couple of ways. Either we can hook this JSON decode method and print its argument, or we can hook this instruction and print the value of X0 register. Let's first try by hooking the JSON decode method and intercept its argument. So for hooking, again, we are going to use Frida framework, but this time we are not going to write the script from scratch. Instead, Blutter has generated a Frida script for us, which contains all the boilerplate code required for hooking, right? Which is basically this Blutter Frida JS script. Let's open it up. Okay. And I mentioned that Dart VM does not follow ARM64 calling conventions completely. So if you try to intercept the function arguments like you used to do with any other ARM64 binary, chances are that you will end up with garbage data. And that's where this auto-generated Frida scripts come into picture. Let's first have a look at this script and try to understand what's going on over here. So immediately you can see that the registers are being mapped into their respective variable names. For example, X15 register of ARM64 is being used as a stack register in Dart VM snapshot. Okay. Similarly, X22 register of ARM64 is being used as a null register in Dart AOT snapshot. Similarly, X28 register of ARM64 is used as a heap address register. So this basic mapping has been done already in this Frida script. So you don't have to bother about the registers. And then it's calling this try load lib application function, which is nothing but it's simply waiting for libapp.so being loaded into the memory. And once it's loaded into the memory, it will call on libapp loaded function, which is this one. Over here, you see there is this dummy function which says remove this line and correct the hook value. So let's just simply remove this line And then we have the function address, which is currently assigned as the dummy value. So this function address we need to replace with our target address, which we have identified from our analysis, which is this address where the JSON decode function is being called, right? So let's copy this address and put it over here. After that, it's calling the interceptor.attach and adding this offset with the base address of libapp.so where it is loaded into the memory, right? So now as soon as this particular address executed by the application, this onEnter method will be triggered, and inside that it's initializing few stuff. So let's quickly have a look at it, and basically here it's assigning the heap address variable. After that, it's calling this get argument function. This function basically returning the address of the argument. Okay, let's see what this function is doing. Inside this function, we can see it's actually reading the value of the argument from the stack by adding few bytes to it. So that's how the Dart VM stores the argument of a function, and you don't really have to bother about the internals. These utility functions would take care of that thing. So you can directly call these utility functions such as get argument to get the address of the argument of the respective function. Okay, let's go back. So once we have the address where the argument is stored, after that it's calling this get tagged object value. This get tagged object value. Okay, so all we had to do in order to intercept the argument of a function is simply put the right address where the function is being called, and rest of the stuff this script will do for us automatically. So here it will print the data type as well as the argument values. Okay, let's save this script and try to run it on our sample application. So for that, let me go inside ADB shell, and that's where I have my Frida server present. So obviously, to attach your Frida script, first of all you have to start the Frida server on your target device. Once the Frida server is started on the device, you can run this command -u to attach to the USB, then -f to forcefully spawn a new instance of the application, followed by the package name, which is pavan.app.funnybone, and then -l to list our script, which is blutter_frida.js, right? Let me bring the device on top. Okay, hitting enter, and there we go. Application is launched again, and in the terminal we are able to intercept the joke in the form of key value pair, right? So first of all, it's telling that it's a string value present at this address. So this address is the heap address where the string is actually loaded, and then this is the string itself containing the joke as the key, and the value, which is the joke itself. Cool, we have managed to intercept the joke. Let's also wait couple of seconds and see whether it's able to intercept the joke which is being fetched periodically. Yes. So our script is capable enough to intercept all the jokes which is being rendered on the screen. Awesome. Similarly, instead of hooking this JSON decode function, we can attach our hook onto the instruction itself and dump the register value using hex dump. The reason why I am saying to use the hex dump instead of directly using read UTF-8 string or read C string method of Frida is because the argument value is not always starts from the beginning of the argument address. It's actually loaded after certain bytes. So that's why it's better to dump the hex of the register. You can try this by yourself. And if you face any issue or challenges, feel free to post it in the comments or in our Telegram channel. I am sure if not me, someone from our community will definitely help you out. Okay. Now, as a next step, sometimes we also want to tamper the data, right? So here we will try to tamper this joke before it gets rendered on the screen. And for that, we need to modify the contents of the joke which is being present in the memory before it gets processed by this JSON decode method, right? So for that purpose, actually, we can use the same hook and modify the contents. But like I said, we cannot simply write the contents on the argument address itself, which is stored in this object pointer, right? We first need to understand how this function is parsing the argument. So let's go to the definition of this function. Inside this function, there is this if statement, which is basically checking whether the argument address passed to this function is actually part of the heap address or not. If it is not part of the heap object, then it will simply reject it. Otherwise, it will call this decompress pointer. We don't have to bother what this function is doing. After that, it's basically subtracting 1 byte from the object pointer, you can say. After that, it's calling this get object value, and this function takes the pointer and a class object. So this class object is nothing but the type of the argument. So it will tell what type of argument the function is having. For example, whether it's a boolean argument or integer or string, right? So let's go into this get object value now. Whoa. This function is basically returning the value of the argument based on the class name. For example, if the class name is string, it will call get Dart string function. Then finally inside this function, it's calculating firstly the length of the string, and then it's adding this data offset to the pointer which was passed earlier. Okay, so this is what we are looking for. Instead of reading this memory, we want to write into it. So to keep things simple and consistent across the script, let's create a new function called set dart string. Let's pass these two arguments as it is, and also let's have this length over here as well. Now, obviously, we don't want to return anything. We just want to write into this memory location, right? Now, before making any changes to the memory address where the joke is stored, we need to make sure that the length of the data which we are writing is same as what is already stored. Okay, so for that, we have copied this line which will tell us the length of the joke. After that, let's create a variable called compromised joke and assign a new joke to it in the form of string. Make sure to store this joke as key value pair so that the app logic would process it and render it on the screen. For that, let me copy this joke. Okay, and now instead of this joke, I want to store a compromised joke. Let's say, haha, you have been compromised. Okay, I hope this is clear. Now, next we need to build a logic to make sure that the length of the compromised joke is same as the length of the original joke, which is pointed out by this length variable. For that, let's make use of repeat function, and let me store that into a variable called padding, and I will simply repeat this space character, okay, until the length of the compromised joke becomes equal to the original length of the joke. So for that, what we can do by utilizing math.max function, 0 comma length minus our compromised joke dot length. Okay, now finally what we can do, we can create another variable called final joke and append these two values, which is compromised joke plus padding, right? By doing this, the length of the joke will become equal to the length of the original joke, but there is a catch. You see here we have this slash n and this closing curly braces, which basically tells that joke is ending over here. And what we are doing here is that we are appending our padding after it, which will break the joke. To fix that, we need to make a small adjustment. You see, these are basically, including this double quote, we have in total 3 characters, right? So what we have to do, we have to subtract 3 characters from here, and we have to remove these from here and append it over here. Okay, I hope it's clear. Basically, I have just appended the compromise joke with the padding and then ended it with the curly braces and the slash n. Okay, so this is the final joke, and then this is what we have to write to this memory location using UTF-8 write method like this. For debugging purpose, let me also put a console log and print the compromised joke like this. Okay, now what we have to do is call this set dart string method in our hook, which is this one. So let's keep this code as it is. So firstly it will fetch out the real argument value and print it, and after that we will modify the argument. So over here we have to pass in two arguments, right? One is the pointer and another one is the class. So class we have already present in this class variable, but there is this pointer which we still need to calculate. So if you remember previously in this get tagged object value, the pointer which is being passed in this get object value is actually this t pointer minus 1 byte. So let's copy this and to paste it over here, and now this pointer we can pass over here. That's it. So now this will write our compromise joke into the memory address, and then again we need to call this get tagged object value in order to print our compromised message on the console, obviously. Otherwise it's not really needed. And the reason why it's throwing out this error is because it's a constant and we are redeclaring it. So instead of constant, let's make it variable. And that's it. Let me close the previous instance, and here is our application, and this is our Frida script. Let's run it again. And in the console you can see this time this is the original joke, and instead of it, it's printed out the compromise joke, which is this one. Awesome. Let's see whether the same has been reflected on the UI or not. Just scroll down, down, down. Nice. The last joke, if you are able to see, it says, haha, you have been compromised. Let's wait for a couple of seconds so that another joke will get loaded. Nice. Awesome. So we have managed to interpret the joke, as well as we have managed to temper the joke with our compromise joke. I hope you enjoyed this video and learned something new. And I am planning to make a dedicated series on reverse engineering Flutter Dart Snapshots. So if you are interested, stay tuned for that. And if you are still here, I appreciate your engagement. And if you have any questions or comments, feel free to share them in the comment sections down below. Additionally, if you found the material valuable, consider giving it a thumbs up and subscribing to the channel. You are also welcome to join our Telegram channel to stay connected with FatalSec community and contribute by sharing knowledge.